Hello and welcome to fourth quarter. So we are moving right along. I'm hoping that today's video and lesson won't be too long, kids. Hope you had a good spring break. I'll be seeing you on Wednesday, of course. Maybe I'll see some of you at office hours on Monday, the 4th. Actually, the 5th, I guess. I guess Sunday's the 4th. Anyway, here we go. We've done problems like these two openers before. I do want to look at this first one. Whoops. Just because it's something that people sometimes forget and need a little help with. So we know that that's 28 degrees. We know the Vx bisects. This V is supposed to be right here. Sorry about the lousy diagram. So if I call it bisects, so I call that A and A. I'll call this F and F because we have bisection going on over there as well. So you realize, you know that all the angles of a triangle, we have to find angle X. That's this angle right here. We know all the angles of a triangle add up to 180. So if I take out this 20, 2A plus 2F has to be 160. And then again, we've seen this before. Everything's even, right? So A plus F has to equal 80. Now, we don't actually have enough information to solve for A or F, but it's okay. We don't need to. We know that the sum, now we can look at this small triangle here in the bottom. A plus F is 80. So angle X, of course, is 100 degrees. So sometimes you don't have to solve for all the unknowns. Just solving for the sum was sufficient. Okay, there's a proof, right? We haven't done proofs here in a little bit. I don't want you to forget about proofs, and we're not totally done with them yet either, just so you know. But I'm not gonna, there's nothing new here. This is just practice. I will give you a couple hints though, and then you can do this one yourself. You can check. I'll have the solutions posted on Canvas, of course. I have, let me think here. So I realize I'm missing a step in my solutions. I have 12 steps for this problem. I don't know if that's the quickest way. On my solutions that I'm going to post, there'll only be 11. I'm missing, there should be a draw step in here. So there's a hint as to how I did it. A big hint, obviously. That might not be the only way to do it. You might be able to come up with another way, but it's pretty lengthy. I had a double-digit proof. So I had it looks like 12 steps with a draw step. Okay. All right, now let's get into what we're doing here. So polygons, so far we've just been talking about triangles, a ton of that, and quadrilaterals, right? But we've mentioned some of these other ones, but not as much. Pentagon, hexagon. The seven-sided one has a couple different names. It could be called a heptagon or a septagon. We haven't talked about that at all. It's not as common. And then, of course, you can follow the prefixes: octagon, nonagon for 9 sides, decagon. Now, I think most of those names, I'm expecting you to know all these names, okay? But I think they're pretty obvious up through number 10. 12 and 15, you might have to spend a little bit of time on. This is a dodecagon. Makes sense, though, when you think about it. And then this one is the 15-sided is a pentadecagon, okay? Anything that's not listed here, we're just going to call it the number of sides and then say gon. So like if it was an 11-sided polygon, we would say an 11-gon. If it was a 20-sided polygon, we would say a 20-gon. If it was a million-sided, we'd say a million-gon. Okay, so everything that's not listed there is going to be the number of sides and the gon. What is the sum of the angles of the 5 angles in this pentagon? So the way we're going to do this, and maybe you guys already know, pick one vertex. I'm going to pick this one here and draw in however many diagonals you can from that one vertex. You realize we can draw in two of them. And hold on, let me do the same thing over here. I'm going to pick this vertex. Here I can draw in one more. But what did I form? When I drew in these diagonals, I formed, in this case, 3 triangles. Okay, we know that the sum of the angles of a triangle is, of course, 180. So 180 times 3, all those angles of the pentagon would have to be 540. Here we have 4 triangles, so 4 times 180 would be 720. Okay. Now the general formula, I hope you realize what happens here is in this 5-sided figure, we formed 3 triangles. In this 6-sided figure, we formed 4 triangles. If we had a 7-sided figure, we would form 5 triangles. So we're going to form 2 fewer triangles than we have sides. So the formula, here's one of the formulas for today. The sum, what this stands for is sum of the interior angles is going to be 180 times n minus 2, n being the number of sides. So subtract 2, that gives you number of triangles, times 180. That's the sum of the interior angles of a polygon. When we're talking about angles of a polygon, folks, you should always assume the interior angles unless you're told otherwise, okay? You're always assuming you're talking about interior. Now here in this next problem, it says the exterior angles. First of all, let me let you know what an exterior angle is. Exterior angle, if I take a side of a polygon like this and I extend it, okay, this is an exterior angle. The exterior angle is supplementary to the interior angle. There's only, when we're talking about exterior angles, we're talking about 1 per vertex. So I could extend this, and that would be an exterior angle. I could extend this, that would be an exterior angle. Now realize I could have extended this one instead. That would have been the exterior angle then. But you wouldn't, I mean, they're both exterior angles, the one I erased plus this one. But if we're talking about the sum of the exterior angles, we're talking about 1 per vertex. And this one I'm not going to get into much. The sum of all the exterior angles of any polygon is always 360. Okay? Think about it. If you extend this, extend 4 of these in this rectangle, you're going to have exterior 4 90 degrees exterior angles, adds up to 360. In a pentagon, if it was regular means it's equal angular. Remember, we know that the sum is 540. Divide by 5. There's 5 vertices. Each one of these is 108. So the exterior would be 72, and there'd be 5 of those. 5 times 72 is 360. You can mess around with it. So there's 3 main things you need to know today. We've done 2 of them. First one's this formula here, sum of the interior angles of any polygon. It doesn't have to be regular. This is any polygon, and any kind of polygon is 180 times n minus 2. And then the sum of the exterior angles of a polygon, 1 per vertex, is always going to be 360. There's one more formula that we need, and I'm going to write down the formula and then explain where it comes from. The number of diagonals, this is total number of diagonals, okay, that can be drawn in a polygon of n sides is going to be this, n times n minus 3 over 2, okay? Now let me explain where this is coming from. Okay, let me go back to the previous. So the n minus 3, think about it. From one vertex of a polygon, you cannot, how many different diagonals can you draw? Well, realize you can't draw one to the vertex to the left, because that would just be another side. You can't draw one to the vertex to the right, because that would be another side. You can't draw one to the vertex you're standing on. So that's where the n minus 3 comes from. You can't draw to this, this, or that. So I could draw there, and there. So that's the n minus 3. Now the n in front, oh, I got disappearing ink. That's not good. Let me see if I can get this to stick again. Now the n, of course, is you slide over and do this from every vertex. Okay. Right? Now I slide over here, and I can draw this one, but I've already drawn this one. And then I slide over here, I've already drawn them both, and I slide over here, I've already drawn them both. So that's where the over 2 comes from, is because, each diagonal has an endpoint of 2 different vertices, right? So you don't want to double count them. So this is the total number of diagonals that can be drawn in a polygon. N times n minus 3 over 2, because you can't draw it to yourself, can't draw it to left or right, multiply times the number of vertices, don't double count. Now remember, that's the total, okay? The number of diagonals that can be drawn from any one vertex in a polygon is just n minus 3. And here's some problems to do. I'm going to go through a couple of them. A couple of them I'm going to leave for you to do on your own. You can just check the answer key. What is the name of the polygon with 35 diagonals? Be careful with this problem. A lot of times people go too quickly and they get it wrong. They just say 35 gon. Remember, it doesn't say 35 sides. It says 35 diagonals. So 35 diagonals, okay, over 2. I'm going to cross multiply, and I'm going to do 3 things at once. I'm going to cross multiply, I'm going to distribute this, and I'm going to move this over and set it equal to 0. So I'm going to get n squared minus 3n minus 70 equals 0. Do a little factoring. Clearly, I'm going to use 10 and 7. And I get the negative answer, which makes no sense. Having a negative number of sides doesn't make any sense at all. Remember, that's not my answer, though. 10 sides means they were asking for the name. So my answer is actually a decagon. Okay. Sum of the measures of angles of a nonagon. Of course, nonagon minus 2 times 180. Boom. Easy. A lot of this stuff is pretty easy. How many sides does a polygon have if the sum of the interior angles is 1440? So here you're given the sum. I'll leave that one to you. You should come up with 10 sides. Find the sum of the measure of the exterior angles. Well, remember, sum of exterior angles. No thinking necessary there, right? How many diagonals does a 350 gon have? Well, that's just plugging in. You're going to get a big answer there. You can check that one on the answer sheet as well. Okay, here's a couple that I'll probably walk through, but you should really try them first. Okay. 2 consecutive angles of a hexagon are right angles. The remaining 4 angles are congruent. Find the, okay, well, the hexagon sum is 720. 2 of them are right angles. So what's remaining is 540. Man, this is easy. Divide by 4, 135, because they're all congruent. And the last one, the measure of one interior angle of a regular polygon is 165. Remember, it doesn't say that this, well, find the number of sides of the polygon. So let's think, it says it's regular. Remember, regular means all sides congruent, all angles congruent. So if one of them is 165, 165 times n would give us the sum. Well, we know the sum formula is 180 times n minus 2. So now we can just solve that by doing a little distribution. Subtract that 180n, and we get 24 sides. So that's a pretty straightforward lesson. Just want to ease you back in after spring break. I think we're just going to call it there, and we'll do more on Wednesday. All right. So remember, three main things here with this lesson. The sum of the interior angles of any polygon is going to be n minus 2 times 180. The sum of the exterior angles of any polygon is going to be 360. That's if you have one per vertex. And then lastly, the number of diagonals, the total number of diagonals in a polygon is n times the quantity n minus 3 all over 2. Okay? And yeah, the solutions are on Canvas for the sheet. You'll have an assignment due Wednesday. Have a good one.